This lesson is for section 3.3, solving conversion problems. We're going to look at only one-step math problems in this lesson. The learning goal is to be able to multiply a measurement by a conversion factor. Let's take some notes on that learning goal. There are two vocab words. First is conversion factor. This is a ratio that's equal to 1. That means the numerator and denominator are equivalent measures. Here's an example conversion factor. 1 meter is equivalent to 100 centimeters. 60 seconds is equivalent to 1 minute. The next vocabulary word is dimensional analysis. This is a technique to solve a conversion problem by examining the measurement units used in the problem. Let's do some example problems to see dimensional analysis. Problem number 1. Use dimensional analysis to convert 35.8 millimeters into a measure that's in meters. The technique works like this. Write down the given measurement, 35.8 millimeters. Make sure you're including the label that gives the units of measure. Then write multiply and draw a fraction line. Whatever this unit is right here, write down in the denominator. Whatever unit you're asked to figure out, in this problem meters, write in the numerator. Now fill in the appropriate numbers to make the conversion factor. 1 meter is equivalent to 1,000 millimeters. This is called dimensional analysis because we're looking at the dimensions or the unit labels in order to create the setup of the math problem. Millimeters cross-cancels the unit millimeters, leaving the unit meters, which answers the problem. Now in your head or on a calculator, do this math work. 35.8 times by 1 and divide by 1,000. You don't really need a calculator because dividing by 1,000 can be done by moving the decimal 3 positions to the left. This becomes 0.0358 meters. Example number 2. Use dimensional analysis to convert this number of micrograms into milligrams. To begin the technique, you write the given value down. 3 times 10 to the negative 3 power micrograms. Then write multiply and draw a fraction line. Whatever this unit label is, put in the bottom. Whatever you're trying to figure out in this problem, milligrams, put in the top. Then fill in the numbers to create the equivalency. Neither milligrams or micrograms are the basic unit for mass, grams. So to create the equivalency, let's think about how many milligrams and how many micrograms are in the basic unit of a gram. There are 1,000 milligrams in 1 gram, and there are 1 million micrograms in a gram. A quicker way to write a million is 10 to the 6th power. We've used the dimensions, or the unit labels, to set up our math problem. Because micrograms cross-cancels micrograms, leaving milligrams, which fits what we're asked for, we know we have the correct setup to the problem, assuming we've written the right numbers in the ratio. Now take a calculator and type this math in. 3 times 10 to the negative 3rd power times 1,000 divided by a million. The answer is 3 times 10 to the negative 6th power milligrams. And the next example for your notes. How many cubic centimeters is 2,500 milliliters? Let's use the dimensional analysis technique. Write down the given quantity, 2,500 milliliters. Then what do you write? You write a times symbol and draw a fraction line. What unit goes down here in the bottom? It's milliliters, to match this one here so that they'll cross-cancel away. Which unit goes right here in the top? It's centimeters cubed, the unit that you're asked to figure out. Now we need to fill in the values. By definition, 1 cubic centimeter is equivalent to 1 milliliter. The label milliliters cross-cancels the label milliliters, leaving centimeters cubed. and 2,500 times by 1 is still 2,500. On the next page of the notes is a summary of the dimensional analysis technique for solving a conversion problem. You write down the original measurement with its label. Then write multiply and draw a fraction line. In the denominator of that fraction, you need to have whatever the original label is. Because this label will match this label here, they will cross cancel. In the numerator of that fraction, write down the new label, the one that you're trying to create. Then fill in the numbers into the fraction to create your conversion factor ratio. This concludes the video lesson on using dimensional analysis to solve conversion problems. Here are some check for understanding questions. Use that dimensional analysis technique and make sure you show your work steps to answer these problems, and then we'll discuss them.